The polynomial p of x is given by p of x equals x cubed plus 2x squared minus 5x minus 6. Use the factor theorem to show that x plus 1 is a factor of p of x. Express p of x as the product of three linear factors. Verify that p0 is greater than p1. Sketch the curve with equation y equals p of x, indicating the values where the curve crosses the x-axis. So I've got the question summarized here. Let's show that x plus 1 is a factor then. So here we need to work out p of minus 1 and show it equals 0, don't we? By the factor theorem. So it's minus 1 cubed plus 2 times minus 1 squared. Put it in here. Put it in here. Minus 5 times the minus 1 minus 6. Minus 1 cubed is minus 1. This is 1 times 2 is 2. This is a plus 5, isn't it? Minus times minus, take away 6. So we end up with 1, take away 1 is 0. So yes, it's a factor. Part 2. Now, x plus 1 is a factor of p of x. So x cubed then plus 2x squared minus 5x minus 6 must equal x plus 1 as a factor times so many x squareds plus so many x's plus the constant. And we need to work out a, b and c and factorize it. Okay, so let's have a look at this then. So here, let's equate x cubes. There's 1 on this side, and when you expand the brackets, there's only going to be one a lots of x cubed here. So a equals 1. Now we'll look at the constant next, because there's only one constant. Just equate those. Minus 6 on this side is equal to, and we end up with a c on this side. So c equals minus 6. It just remains to get b. We can get it from the x squareds or the x's, can't we? Should we do the x squareds? Yeah, let's do the x squareds because a is 1, and that's easier. So equate x squareds. So on this side there's 2. On the other side, the x squareds arise from the 1 times a, which is a, and then the x times b, which is bx squared. So there's a b there. So b is equal to 2 minus a, which is 1. B equals 1. So b equals 1. So this is equal to then x plus 1. I'll just put it here, x squared plus bx plus x minus 6. Okay, so we got x plus 1 then. And here we can factorize. This is an x and an x to give the x squared. 3 2's, we've got a plus, so it'll be plus 3 minus 2 will give the middle term being 1, won't it? X squared plus 3 minus 2x's is 1x. Minus times plus is a minus, 2 3's is 6. So we've got our cubic. Now part C. Oh, verify part P0 is greater than P1. So B, P0 then, and P1. If we put 0 in to our cubic, we'll get 1 times minus 6, won't we, which is minus 6. If we put 1 in, we'll get 2 here, and then we'll get 1 minus times minus 1, because 1 goes in here, and then we get 4, which is equal to minus 8. So P1 then, minus 8, is going to be less than P0. Minus 8 is less than minus 6. Now part C, we need to sketch the curve for part C, indicating the roots. Here's the roots here. I'm going to do a quick sketch here. The cubic goes up, down and up, or down, up and down, basically. So here's our little sketch, which I'll put in here. And the y-axis and the x. The roots are at minus 1, 2 and minus 3. So let's put minus 3 here. And then the other root is at 2, which we'll put here. And the other root is at minus 1. So there's the roots. We indicated where it cuts the x-axis. Now it's a positive x cubed, so it's going to come down, up and down, isn't it? That way around with the x cubed, because it goes to infinity as x tends to infinity. So I've got a digital pen, so I'm going to use dashed lines because it's easier for me to draw it. It's going to come down, go through here. P0 is minus 6. We could indicate that value on the sketch, just for the sake of completeness. Turns and goes back down. P1 was the value minus 8, so it's going to come lower here, isn't it? So I'm just going to redraw that little bit here, just to show that actually happens on the curve. There, and then it's going to come back up. And that was P1, that value that we worked out here, minus 8. But we don't need to put it in for the sketch. And this is y is equal to P of x.